Everything around us is connected. Our phones, computers, and even smart devices. But have you ever wondered how they communicate? Let's find out. Yes, you are right. Computer networks. They connect devices and allowing them to share information instantly. But who was the first to think about connecting computers? And where did this idea come from? What problem did it solve? And why was networking even necessary? How did early computer networks actually work? And what was the key idea behind them? What about today? How do networks shape the way we live and communicate now? These are the questions we'll answer in this lesson. So, let's get started. Welcome to our first lesson on computer networks. My name is Ali, and I'm excited to have you here on this journey. Let's take a trip back to the 1960s. Back then, computers were huge, expensive, and worked completely alone. If a company had computers in 3 different cities, there was no way for them to share information directly. This was a big problem, especially for researchers who needed to work together. If they wanted to send data, they had to print it out or save it onto a tape and physically mail it. Can you imagine waiting days just to transfer a simple file? Now, here's where Robert Taylor comes in. He was a project manager at ARPA, a U.S. government research agency. One day, he looked at the separate computer terminals in his office, each connected to a different machine in a different city, and thought, why can't these computers just talk to each other? So he pushed for a new project, one that would change everything. His idea? To connect computers so they could share information instantly. And with the help of some brilliant minds, this idea became the very first version of the internet. But hold on. Connecting computers wasn't as simple as just plugging in some cables. There was a big problem that needed solving. Let's talk about it. Alright, so now computers were connected, but there was a huge issue. How do we send data between them without crashing the entire system? Back then, networks worked like telephone calls. One direct connection between 2 computers. That might work for a small number of machines, but imagine if thousands of computers needed to communicate at the same time. Think about it like this. What if every time you sent a message, you had to create a separate, dedicated line just for that conversation? The whole system would slow down, and eventually, it would completely crash. Researchers needed a smarter way. Instead of one long, direct connection, they thought, what if we broke messages into smaller pieces and sent them separately? That way, the system wouldn't get overloaded. And that's exactly what they did. They came up with something called packet switching. A way to break data into small chunks, send them along different paths, and then put them back together at the destination. It was a game changer. This method allowed multiple computers to send and receive information at the same time, making networking faster, more reliable, and scalable. In fact, this is the foundation of how the internet still works today. But what exactly is packet switching? Actually, this is exactly what we are going to learn throughout this entire course. But right now, let me give you a quick and simple explanation. Instead of sending entire files as one large piece, data is broken down into smaller packets. Each packet is like a tiny letter, carrying a piece of the message. Every packet contains 2 important things. 1, a destination address, so it knows where to go. 2, a sequence number, so it can be put back in the right order. Once all the packets arrive at their destination, they are reassembled like a puzzle, forming the complete file again. And this revolutionary idea led to the birth of the first real computer network, ARPANET. Without packet switching, networks would be too slow, inefficient, and unable to handle the amount of data we send today. So the next time you send a message or stream a video, remember, you're actually sending thousands of tiny packets, each traveling separately to reach the same destination. That is, the power of packet switching. And then, history was made. On October 29, 1969, the first message was sent from UCLA to Stanford. It was a historic moment. the very first attempt to transmit data over a computer network. Robert and his team excitedly watched as the characters were sent through ARPANET. The message was simple but important: LOGIN, login. But then something unexpected happened. Just after the first two letters, L and O, were transmitted, the system crashed. The only message received on the other end was L and O. A failure? Maybe. But in reality, it was the beginning of something revolutionary. That tiny, incomplete message, just two letters, marked the birth of the internet. It was the first time in history that two distant computers had ever exchanged data. Today, billions of people are connected through networks built on this idea. Everything we do, sending emails, browsing websites, watching videos, traces back to this very first message. All right, so we've talked about how networks started, but what do they look like today? If you're like most people, you probably don't think too much about networks. You just expect your internet to work. You sit down at your computer, connect to Wi-Fi, and start browsing, streaming, or working without worrying about how everything is connected. But behind the scenes, your home is actually a small network of its own. Your devices, your computer, laptop, smart TV are all connected to a router, which acts like the bridge between your home and your internet service provider. But networks aren't just in homes. They power entire businesses too. Large companies, known as enterprises, have much more complex networks. Instead of just a single router, they have multiple switches, routers, and firewalls connecting hundreds or even thousands of employees to their own private network, which is then linked to the internet. But whether it's a small home network or a massive enterprise system, the core idea remains the same. Devices need a way to communicate and share data efficiently. And that's where standards come in. For all of this to work seamlessly, computers need to follow specific rules for communication, which are essential for network engineers to learn. And that's exactly what we're going to learn in the next video. TCP/IP, the fundamental set of rules that keep networks running. So get ready. I'll see you in the next video.